Hello and welcome to this revision lesson on probability. Once again, get yourself a pen and some paper handy. Right, let's begin. A bit of knowledge retrieval, some skills that are often needed in probability questions. As usual, pause the video, pick the right answer, resume the video and see if you're correct. So here we go, number one. Right, question number one. In order to simplify a fraction, you need to divide the numerator and the denominator by the same thing. 2 goes into both numerator and denominator. 4 divided by 2 is 2. 10 divided by 2 is 5. Therefore, B was the correct answer. Right, have a go at this one. Right, in this question, the number that goes into both numerator and denominator is 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So correct answer was C. Number 3, work out 1 take away 0.7. If you write it like this, it might be easier to see that the correct answer is 0.3. A was correct. Next one. Right, a fair dice contains the numbers 1 through to 6. Mark on the probability scale the probability of getting a 7. 7 is impossible. There is no 7 on a fair ordinary dice. So A was the correct answer. Next one. Right, once again, fair dice numbered 1 to 6. Even numbers are 2, 4 and 6. That is 3 outcomes out of a total possible 6 outcomes, which simplifies to 1/2. So B was correct. And the next one. Right, once again, numbers 1 to 6, the probability of getting a number less than 8. All of the numbers are less than 8, therefore it's certain to get a number less than 8. Therefore C was the correct answer. The last question, where it's easy to see how many total outcomes there are and how many of each suite. It's a bit less clear on this. So your starting point is to try and list all the outcomes that there are, and a table will help you do that in a really neat and efficient way. So you can get a head on the coin and a 1 on the dice, or a head and a 2, and so on. And if you complete all of the table, tail and 1, tail and 2, and so on, what you get is you get a list of all the possible outcomes when you flip your coin and you roll your dice. So what's the probability of getting an even number on the dice and a head on the coin? Well, we can see there's 1, 2, 3 ways in which that can happen out of 12 possible outcomes altogether. That would simplify to 1/4. Right, pause the video, have a go at answering those questions using the same table from the previous slide. Right, probability of getting a tail on the coin and a 6 on the dice. There was one way that could occur out of the 12 possible outcomes in the table. And the probability of getting a head on the coin and a number less than 3 on the dice, well, that could be a head and a 1 or a head and a 2. So that's 2 out of 12 total possible outcomes, or 1/6. And to finish off with some exam questions, so pause the video, read the question carefully, make a note of any keywords, break it down into steps and do one step at a time. Right, 49 counters in the bag. 20 of the counters are red and the rest of the counters are blue. So first thing we should be doing here is working out how many blue counters there actually are. 29. One of the counters is taken at random, find the probability that the counter is blue. So if there are 29 blue counters and there are 49 altogether, there's my probability. Same idea here. Pause the video, read the question carefully, make a note of all the keywords, break it down one step at a time. Right, so we've got a fair dice and a fair spinner. Is Charlie more likely to get a number less than 3 on the dice? Well, what would the probability of that be? There's 2 numbers less than 3, 1 and 2, and there are 6 outcomes altogether. So the probability of getting a number less than 3 is 2 over 6. Or a number greater than 5 on the spinner. What's the probability of that happening? There are 1, 2, 3 numbers greater than 5. And there are 8 outcomes on the spinner altogether, so therefore the probability of getting that is 3 over 8. What's Charlie more likely to get? Well, we need to have a look at these and decide which is the biggest probability. And I think possibly the simplest way to do that will be to turn them all into fractions over 24, because 24 is the lowest common multiple of 6 and 8. So 6 times 4 gave us 24, 2 times 4 gives us an equivalent fraction. 8 times 3 is 24, so 3 times 3 gives us an equivalent fraction. Common denominator, so we can see that this one is more likely. Charlie's more likely. And one more question. Pause the video, read it carefully, underline the keywords, have a go. So we've got 3 numbers in box A, 3 numbers in box B. He takes cards from box A, box B, and he adds the numbers together. So what's missing is the scores that he could get. So it's going to be worth listing all of those, and the table that we saw in a previous question will be helpful for this. So if you've got a 3 from box A and a 2 from box B, that's a total of 5. 3 and 3 gives you a total of 6, and so on. Complete your table showing all of the possible outcomes first of all, and you can see there are 9 possible outcomes. That will be the denominator of your fraction. Work out the probability that the total score is an odd number. So we've got 1, 2, 3, 4 odd numbers, giving us a probability of 4 out of 9. And another question to try. Right, we've got 100 counters in total, 30 of them are blue. What's the probability that the counter is not blue? Well, if there's 100 altogether, 30 blue, that leaves 70 not blue. So the probability of choosing one that's not blue is 70 out of 100. And if the ratio of blue to green is 2 to 3, blue to green is 2 to 3, and if the number of blue is 30, then hopefully you can see that this number is 15 times more. So to get an equivalent ratio, we need 15 times more than 3, which is 45. 45 green counters in the bag. If you need more practice, there's a couple of Sparks Maths independent learning tasks you can go and have a look at.